Hello, Fusion fans. My name is Byboth, and I'm the Director of Power Business Development at Commonwealth Fusion Systems. Thank you for the Fusion Report team for the great opportunity to present to you today. It truly is an exciting time to be involved in Fusion, and I can tell you that the team at CFS is working as hard as possible to bring Fusion power to the grid as fast as possible, working around the clock to make it happen. The prompt today's session was about a shot clock. Shot clock is an analogy. In basketball, when the shot clock reaches zero, you lose the chance to score and you turn the ball over to the other team. Framing this analogy to fusion, it might be interpreted that the shot clock could expire if we don't have commercial fusion by 2035. I don't think this is the case. If I were to pick a different analogy, I might pick the white flag that signals the last lap in a long race. This acknowledged the decades of work by the giants whose shoulders we stand on today. The last lap signifies a sprint to the finish line for commercial fusion, a race to establish leadership in any industry, to be the first into the deep blue ocean of commercial fusion. And that leadership matters. The first ones to grab a commercial footing will influence the future of energy substantially. China's advancing fast has made progress rapidly up the pack in the last few laps, but I'm confident that fusion will see the finish line. But for all the reasons that the shot clock will not expire, that may be just the start of another race to scale. Before I jump into the CFS approach, I want to revisit why I don't think the shot clock is going to expire and result in a turnover to another technology. We are in the middle of the largest industrial transformation in history, and there are lots of different projections for clean energy demand. And while they may agree or disagree, what they all do agree on is that it's going up tremendously, potentially even doubling by 2035 already. And this is being driven by the electrification of everything from intelligence to industry to transportation to heating and cooling. The more you think energy is a technology and not a resource constraint, the steeper the line on the graph. This graph is in gigawatts, but you can generally translate that to gigadollars, which is an enormous opportunity, a multi-trillion-dollar opportunity. We're going to need to build about 3,700 new power plants to replace the existing ones. And that's not even considering what would happen if the energy demand were to double. Those 3,700 power plants that make up 85% of the world today generate about $1.8 trillion a year in revenue. So tremendous opportunity. And if you look across a range of technology options that could potentially provide for this, almost every available technology, existing or emerging, has some sort of trade-off, be it the reliability or the siting availability, or even just the cost in general. Only fusion has the potential to check all of the boxes. Really, the only problem with fusion is it's not here yet today. If it was, we would sell a lot of fusion power plants. And there are great things happening in the fusion industry. The Fusion Industry Association members have now raised more than $10 billion in private capital across a wide range of architectures. And this investment is being turned into research and progress at the speed of the private sector. To revisit the racing analogy, we now have a lot of fast cars on the track, increasing the chances of success. And behind those crews are the sponsors and investments necessary to keep them moving and to get them going faster. And while it's not here yet, there's been tremendous progress on key fusion metrics at a pace that's faster than Moore's Law. That progress stalled with the fundamental limits of key pieces of technologies. For CFS, it was magnets. For others, it may be lasers or capacitor banks, or new simulation capacity, or new materials. All those advancements are arriving now and adding to the progress of the past and providing the path forward for commercial fusion. And so I do think that we'll have commercial fusion before 2035. And CFS has been formed with the intent and purpose to do this. We have an approach based on proven plasma physics that's been peer-reviewed and delivered by the largest fusion company with now over 1,000 people and more than $2 billion invested, and a team that knows what it's like to build hard things and knows what it means to manufacture at scale, who is actively engaged not just in the technology development, but the ecosystem development, spearheading a regulatory path now codified into law where fusion plants will be regulated not like fission plants, but like particle accelerators. The licensing can take a year or two, and that's a big improvement from the 10 years and $1 billion for legacy nuclear fission plants. And at CFS, we've taken a deliberate and systematic approach to risk retirement, starting with the physics that we from the MIT's Plasma Science and Fusion Center, and then moving to the magnet technology, which we demonstrated. And not only did we demonstrate that, we demonstrated the ability to stand up a manufacturing line to build these novel technologies. And now we're integrating that known architecture with these new breakthrough magnets in our device SPARC here in Massachusetts. And that project's now about 65% complete. And then beyond that, we've already started the work on our ARC, our commercial power plant. In CFS, we've decided to vertically integrate on the key technologies that we need. We're operating our first factory now. Over 100,000 square foot of manufacturing in Massachusetts with technicians working around the clock making magnets that will be used in SPARC. These magnets are some of the strongest in the world. And we don't only just make the magnets here, we also have all of the test stands to make sure they're made with quality and provide the quality assurance we need to know they'll do what we need them to do when we need them to do it. And I'll show in some pictures here. You can see some of our technicians working to meticulously insert some of the first superconductors into some of the first pancakes that will go into some of the first magnets for SPARC. Or those pancakes stacked together to bake the big magnets with the machines that put them in the right cases. And the cases that can withstand the enormous force that comes from magnets with tens of thousands of amps of current flowing through them. And the types of test stands necessary to show those magnets work. And those magnets are going into SPARC, our pilot plant. This is an actual picture of the machine, not a rendering. It's more than 65% complete and on pace for operations in 2027. SPARC shows that a company like CFS can architect and engineer these types of machines, and that regional constructors and local talent, not the super majors, can construct a fusion machine. It includes a supply chain that stretches across 31 countries. Beyond the technology inside, which is truly impressive, SPARC is the proof point that CFS can execute on complex billion-dollar scale projects. And we have confidence that SPARC is going to work. Self-critique is a core value of CFS, and from the beginning, CFS has been committed to holding itself accountable to science, engineering, and commercial progress. One of the ways we do this is through the peer review process. Since our inception, we have published more than 60 papers and journals detailing out our science and engineering advancements. We use this to provide confidence to the scientific community, to our investors, and to ourselves that the fusion machines we are designing are going to work as intended. But as I said, SPARC is really about demonstrating that ability to execute. So Commonwealth Fusion Systems took over the role of architect engineer for SPARC, and since then has now generated tens of thousands of work order packages to our construction partners to deliver. And in order to do this on the timelines that we're looking to, we must execute with the highest level of quality. And what we've seen is that we're through that 15,000 work orders that have been done, we're now running about a 0.5% construction rework cost to date. That's exceptional. That's better than residential. It's way better than what happens in heavy industry. And it's a proof point at our ability to deliver these projects as designed and as engineered. And these things we're building, they're not little things. These are big, complicated things. Integrated and connected things. But things that borrow from other industries, like these large compressors that are similar to what's used in liquefied natural gas to be able to deliver the cryogenic fluid to keep our magnets cold, to confine the plasmas. And these are systems now that are being commissioned. So we have fluid in systems. We're running pumps, we're running valves, venting systems, turning them on, turning them off, getting operations instructions written for all these systems in order to support the tokamak operations. As we move from building and system support construction and into tokamak assembly, a lot of the long lead part items that we've ordered many months ago are now starting to get ready for shipment to CFS. And ensuring the quality of those parts and those vendors around the world has been a big effort. So I said there may be 31 countries that are in the supply chain. On a given day, CFS has an employee in about 15 different countries working with our suppliers, ensuring these items are going to be delivered as expected. And SPARC will pave the way for ARC. Of the 17 systems that you need to make a power plant, 13 of them will be demonstrated at appropriate scale inside of SPARC. And the remaining systems are being tested and demonstrated in other experiments. SPARC also will give us a lot of confidence in the commercial viability of ARC. Because we've been able to collect the receipts from over $1 billion spent, we now know how to make all of the major components that we'll need for ARC. And we know how to talk to our suppliers to gain the estimates and cost, to give confidence to our investors that we are going to be able to build commercially relevant and commercially viable fusion power plants in the future. And while we continue to work on SPARC, a lot of our focus is moving towards ARC. This is where I spend most of my time thinking about. ARC will be our commercial power plant. This will be the one that we expect to have on the grid in the early 2030s, before this 2035 shot clock. It'll be about a 400 megawatt electric power plant that can be connected to the grid as a grid scale asset that can be flexible. We can ramp it up or ramp it down. We're working on the process now of getting that line for interconnection with the PJM grid. And we're really excited about the potential and the site that we've got picked out for it. That site is an ideal site for the first commercial fusion power plant. Located about 20 minutes south of Richmond, about an hour and a half south of Washington, D.C. Located adjacent to a coal plant near the James River and I-95 for logistics with a rail spur attached. It really is an ideal site for a first power plant. But beyond that, it's also the site of some tremendous partnerships with the state and the county, and a lot of work going on to educate and inform our residents and our neighbors as we get ready to build our first power plant. And that project's very much under development now. We have an active zoning case. We're meeting and engaging with the county and the officials and the community to get ready for that. So it's very much steps taken towards the permitting and actual development of that project. And work's underway on the detailed design of ARC today. And here's a first rendering of what the plant may look like, sitting on about 25 acres of built-out land, connecting for the first time a steam turbine to a fusion device to make electricity and put that onto the grid in Chesterfield County, Virginia. But in order to have a commercial industry, it's more than just a technology. One of the things I've been most impressed about my time here at CFS has been the thoughtful approach to building not just a technology, not just a company, or not even just an industry, but a real movement around fusion. And that movement for fusion requires educating and engaging stakeholders that range from the next door neighbor here in Devens that's about a quarter mile away, to heads of state and governors and leaders. And in between, there's a lot of people who we work with in the form of the communities, with our supply chain, with the builders and technicians and constructors of our machines. And that's a global approach to building a movement, not just here in the United States, reaching out to global leaders to try to enforce and develop the right types of regulatory frameworks necessary for fusion. One of those key stakeholders is the regulator. And the long work that's gone into educating and teaching them about the safety of fusion, both in the United Kingdom and the United States, now has us with a framework of appropriate regulations that we can use here to grow an industry, but also can be the template for other countries to take up fusion. And these regulations are not just regulatory here in the United States, they've also been codified into law, ensuring the type of stability that we think we're going to need to grow an industry. And these regulations allow for the competitive differentiation of what fusion can do as a clean energy resource. So it allows us to maintain and standardize our devices and assets as much as possible to keep costs down, to reduce the dollars per megawatt hour, which is really the goal for commercial fusion. I work on the commercial side of the organization here at CFS. And as we thought about the approach to commercial fusion, we laid out a bold vision years ago. It started with a vision that siting could be the start of it. So site it and they will come was kind of the mantra. And that set us on a 2-year search to find the optimal site, as I mentioned before, in Virginia. In addition to that, we knew that there would need to be a customer who could send a signal that represented the incredible demand for fusion and its attributes and its ability to provide that clean energy that's so much in demand that I talked to at the beginning. And along the way, we had thought maybe we could find a utility partner, and maybe they wouldn't be engaged early, but maybe we could get them started on the pathway. We could get onto integrated resource plans. We could start to work with them so they could understand the technology and reduce the time necessary to get our products to market. And then all that would come together with the proof points of the technology to de-risk the future for finance and for investors. And so where we stand today, we made a lot of progress on this goal. And so step one for our journey was siting. And we were, again, very lucky to find the site we did in Virginia. And that with that site came a real partnership And for all the reasons I talked about before, from just a fundamental interconnection point to the grid and as a fundamental infrastructure environment, it was one of the best we found. But it goes beyond that. We found an environment with an extremely talented workforce that was excited about energy. And for us, seeing the opportunity to be a part of this state that's really at the vanguard of a clean energy transition that has growing load demand and a desire for reliable, affordable, and ever cleaner power really had us excited about the opportunity to be a part of what was happening in Virginia. And so also in the site in Virginia, we also have a partner in Dominion Energy. And Dominion Energy is one of the largest utility companies in the country, and showing that you can execute on big projects and innovative things like their work on offshore wind. And so we're excited to partner with Dominion in a joint development agreement that we announced alongside the siting announcement. And that agreement includes, one, the lease of the property, because it's Dominion-owned land that we'll be developing ARC on, but it also includes a partnership to look at how we can learn about operating power plants and connecting them to the grid and lots of great things. And at the same time, we can teach about fusion. And so as I had said, we had hoped that we'd find a partner for some future plant. We were really excited to find one for the very first one, and really excited to partner with the Dominion Energy team as we go forward. In June of this year, Google and Commonwealth Fusion Systems announced a new global milestone, a bold partnership to develop, deploy, and scale clean, secure fusion power. Google signed a power purchase agreement for about 200 megawatts of electricity from our first ARC power plant. Google has also included an option to offtake power from additional ARC power plants. An investor since 2021, Google also deepened its relationship with CFS and increased its investment. We're really proud to have a partner like Google who's had such a long legacy of leadership in advancing clean energy technologies and helping to lead through their procurement of clean energy and the energy transition. And so with now customers that demonstrate the demand for fusion and a site and a utility partner, we've now done a lot to de-risk the potential pathways for commercial fusion, combined with a movement and an opportunity for appropriate regulations and stakeholder engagement with a technology that continues to rapidly advance. We're in a really good spot now to move after SPARC, raise the type of money that's going to be necessary to build and construct that first power plant. And that's a great opportunity for continued innovation in how we think about financing first-of-a-kind projects. But as CFS has shown across the board, we're not intimidated by the need to take on challenges with first-of-a-kind projects. And we look forward to what those outcomes will bring in the future. And so with that, as we kind of wrap up the presentation here, I'll move to close with the same slide I've closed all of my presentations with, which is to imagine this world with no constraints enabled by fusion. And I firmly believe that we will have fusion on the grid before 2035. But I also believe that that's not the end of anything. It's the start of the efforts to scale and grow the industry to be able to provide the type of benefits that we've all talked about for fusion now for decades. So super excited about what's to come, and I look forward to catching up with all of you on the end of the presentations for some questions. Thanks again. Talk to you soon.